episode series. We have completed some episodes our learning journey. In this video, we will start new episode continuous leaning platform. Let's get started.
Press a start button on a factory floor, and instantly, a massive industrial motor kicks into high gear. That reaction feels instantaneous to us, but it is actually the result of a strict, highly structured loop called the PLC scan cycle, executing continuously in the background. If you have been following our series, you already know what a PLC is and the basic role it plays in automating machinery. But knowing a PLC's definition won't help you fix one. To step past blindly swapping out parts and actually troubleshoot a stalled machine, you need to understand exactly how its processor handles information. Let's test this by looking at a standard physical setup, a simple green push button wired directly to our PLC, which is programmed to run a conveyor motor. This diagram shows the core architecture, a four-stage loop consisting of an input scan, program scan, output scan, and housekeeping. Beginning at stage 1, the PLC pulls the physical sensors. It reads the terminal voltage, writing a digital 1 into its internal memory table. You can verify this electrical connection physically. If the button is working, the corresponding input LED on the PLC hardware will immediately glow. Notice that the machine takes absolutely zero action at this point. The input scan exists strictly to build a frozen digital snapshot of the physical world for the processor to analyze. We move to stage 2, the program scan. Here, the CPU reads through your ladder logic program. It evaluates each rung line by line, moving strictly from top to bottom, left to right. Reaching the logic controlling our conveyor, the CPU checks the internal memory table. It sees the digital 1, determining the motor should activate. But the physical motor does not start yet. The decision is updated exclusively inside internal memory. By keeping logic execution entirely isolated from physical hardware, the PLC prevents erratic, chaotic machine movements from occurring while it is still calculating the rest of your code. Only after the entire program has been read do we reach stage 3 on our diagram, the output scan. Now, the PLC bridges the gap back to the terminals. The hardware output LED glows, and the conveyor motor finally spins. The physical work is done, but the cycle isn't over. The final step before the loop restarts is stage 4, housekeeping. During this brief phase, the processor handles tasks you never see. It monitors internal memory health, runs communication checks, and updates system diagnostics. If a module has disconnected or a memory fault occurs, housekeeping catches the error. It will halt the system, preventing a dangerous restart of the cycle. So while the output scan translates your code into motion, the housekeeping phase guarantees the system is safe enough to do it all over again. Now that we have mapped the 4 stages, we can use this exact sequence as a concrete troubleshooting checklist. If an operator presses the physical button, but the input LED stays dark, you know the failure happened at stage 1. You have a broken wire or a bad button, not a software bug. Moving to stage 2, the CPU executes the ladder logic program line by line, checking conditions and making decisions based on the program. And if the entire system halts unexpectedly, you check the diagnostics panel for stage 4 errors, like a communication timeout. Understanding the scan cycle allows you to isolate exactly where a system is failing, moving from guesswork to structured diagnostics. Every action follows this path: the physical button press during the input scan, the digital decision during the program scan, the physical action at the output scan, and the safety verification during housekeeping. This entire precise 4-step sequence loops continuously, repeating its cycle every few milliseconds to keep heavy industry running safely. Now that you understand how a PLC processes information, our next step is to connect the hardware. In episode 07, we will dive into the physical wiring of PLC inputs and outputs. To continue building your skills through this 20-episode series, like this video, share it with your colleagues, and subscribe.
If you are serious about learning PLC and building your career in automation, follow this complete SRITechKnowledge PLC Basics to Advanced Leaning platform. Each episode is designed. Please like this channel Learning PLC and Building Your Career in Automation. Follow this complete. Like the channel, share it, and subscribe the channel.